Here we go. Okay, so good morning again. Welcome and thank you for your interest in the biomedical physics program. I do want to introduce a few people before we get started. I guess since I'm talking, I start with myself. My name is Peter Hoffman, I'm professor in the physics department and teach some of the biomedical physics courses. Although not right now because I'm also the chair of the department and as such don't teach as many courses as I usually do. But my research is in the biophysics and what we call soft matter physics area. That is everything that's soft, fluids and things like that, which obviously is related to biology. We also have, before I introduce the professors, let me introduce the biomedical physics students real quick that we have here. We got Zoe here. Maybe you can introduce yourself real quick.
Hello, my name is Zoe. I'm a second year biophysics student. My major is biophysics and my minor is stats.
Okay, great. And we got, Sarah.
Hi, I'm a fourth year BMP student and a physics minor.
Great. And Roy?
Hi, yeah, I'm Roy, fourth year biomedical physics with a minor in Israeli studies.
Great. And then we have a bunch of our biomedical physics professors here. I'm going to start with the one that joined us the last. That was Mindy. Oh yeah, there you go.
Hi, my name is Mindy Hong. So my research is focused on computational biophysics. So all my lab, we didn't do real experiments. We perform all the tests and experiments using computer. So we study a lot of different biosystems. So for example, we can help like develop COVID drug, just use the computer prediction, and we can also like create a computational microscope, like observe biomolecule motion, just using computer. So this semester I'm teaching the Python class, and I will have a new class, survey of biophysics next semester. So just welcome to join the class.
Great, thanks, Mindy. I think Ashish was the one who joined us first, so I have him talk next.
Hi, Peter. Hi, everyone. My name is Ashish Mukhopadhyay. I am one of the faculty associated with this biomedical physics program from the very beginning. I taught quite a few classes in the BMP program. The latest one was the class that students take in their final semester. That is called Research in Biomedical Physics. My own research is in the area of similar to Peter, like I'm also an experimental soft matter physics physicist. I use mostly the optical techniques. And to give you an idea of what type of research I do, maybe you can think about an analogy, like in a society, say, for example, we manufacture goods at some places, but then they need to get transported at other places where they will be used. Okay, so in our life also, in our body also, there are sophisticated tracking systems or the transport systems where the cargo can get delivered from one place where it is get manufactured to the other place where it can get used. So some of us, like, Professor Sakamoto works on this area of the motor protein, okay, but those ones cost energy. Like in terms of the chemical energy, like ATP, if you are familiar with what I'm talking about. But there are also other form of energy which is always available and free of cost. That is called the thermal energy. And the biomolecules can get transported from one place to another by just using this omnipresent thermal energy. And this process is called diffusion. Okay, so I mostly study the diffusion and in the area of biological context, essentially. We work with the model systems, but many of our results also give insight into what happens in the cellular level, for example. So that is briefly what I do. I'm also looking for undergraduate students to do research in my lab. It can be also be a paid position. Okay, so if you're interested, or if you know some of your friends might be interested, just encourage them to apply to me.
Great.
Thank
Thanks,
you.
Ashish.
Mhm.
Okay, Jifang.
Hi everyone, my name is Zhifeng Huang. I'm also a BMP faculty. Okay, so I'm a theorist. I'm doing theoretical modeling and computation. So I have two different aspects of research. One is about the soft matter, the soft materials, and the other related to the biophysics. And the one I did with biosystem is in collaboration with a friend in medical school in physiology. We studied the cell injury. So injury of cells. For example, you have the neuron in the brain, you have stroke or cardiac arrest. They call it ischemia. Okay, so we study the cell injury, whether the cell die or survive. So we do some modeling, and then so my collaborator in medical school doing the experiments. So I'm teaching actually two courses, and the major one is the introduction to biomedical physics, is 4700. I also taught 3700 is the max, okay, mathematics for biophysics. Okay, so if you have interest in BMP or any question, you feel free to ask me. Okay, thank you.
Great. Yeah. So Jifeng, yeah, he's the official advisor for the program also, and of course,
Right.
I mean the faculty advisor, but our main advisor for all students is Dawn. So I'll let Dawn introduce herself.
Good morning, everyone. It's so great to see a lot of students here that I know. Hope your semester is going well. My name is Dawn Niedermiller, and as Professor Hoffman said, I'm the undergraduate biomedical physics advisor. So if you're interested in the program, please make an appointment with me. When we meet, we actually talk about your interest, your goals, academic goals, what you want to do for your future. And then we plan your courses accordingly, because everybody's different. So we individualize the program to best fit you. There's lots of opportunities with biomedical physics that you'll hear about shortly. If you want to make an appointment with me, then just go to stars.wayne.edu, and you'll find where you can explore majors. You'll find biomedical physics, and that's where you'll find me. So again, welcome everyone, and thanks for coming.
Great. Thank you very much. So I'm going to get started. I have a little presentation, and then we just have some time for questions and answers. So I just want to go a little bit over the program. So let me share my screen with you. 1 second. Hold on. Actually, what I'm going to do is I'm going to first start the presentation on my computer. Okay, there it goes. And now I'm going to share the screen. That's better. Okay, first of all, can you all see that? It's
No problem.
Yeah, good. So it says biomedical physics. So okay, so let's get started with that. So what the first thing is, what is biomedical physics? So it's a degree that we think about as something that combines students learning a deep understanding of the physical properties of the body. You heard of some of the research that some of my colleagues are doing, looking at things from the molecular to the cellular scale, understanding the physics of it. So the physics is the fundamental science, and we're really trying to understand through experiments, computer simulations, and theory how biological systems work. You would learn a lot of analytical skills, because that's what we do. We analyze things using things like computers, experiments, and math. Part of our program is an understanding of medical technology. We actually have courses taught by faculty from the medical physics program. That's a graduate program in the medical school. And they teach about how radiation therapy works, how things like X-rays, CAT scans, MRI imaging, and all this kind of stuff, which is all based on physics, obviously. You will get a training in data science and computer programming. So you just heard that Dr. Wang is teaching a course in that. And you get hands-on experience. We have lots of labs in electronics, optics, and advanced biophysical research. And we have excellent research opportunities. We have our own funded undergraduate research program called the Barber Research Program that not many departments have. And of course, we think that this program gives you an excellent preparation for medical school, any kind of health careers, technological careers, engineering, or graduate school in all kinds of fields. I'm also actually going to show you later what some of our former alumni are doing. I was on LinkedIn yesterday and looked up a bunch of them, and you would be quite amazed what some students do with our degree. Now, did you know that medical technology comes from physics? X-rays, MRI, ultrasound, PET, which is positron emission tomography, radiation therapy, all this was essentially invented by physicists originally. And also that living systems cannot really be understood without molecular biophysics, unless you understand how molecules move, where they get energy from. Professor Mukhopadhyay mentioned ATP. You know, how do molecules in your cells take ATP and start doing all these things that your cells do? That's the kind of stuff we talk about. How molecules are transported. Again, that was mentioned. How they come into a cell, outside of the cell, how they're transported through your body, how is energy transformed. There's electricity in your body. I mean, energy gets transformed into voltage differences that drive basically things that you can consider electromotors in your body. I don't know if you knew that. In your mitochondria, there's all kinds of stuff going on that's really physics-based. And much research is done by computers, so we use a lot of computing. What will you learn if you would be a biomedical physics major? Well, you're learning about cellular and molecular biophysics, computational modeling, modern medical technology, advanced analytical skills, research methods, optics, electronics, and scientific communication. You know, how do you actually talk to people about science? How do you write about science? How do you give a presentation? All those kind of skills that you need to be successful as a researcher and as a professional in any field. Recently, we have made some changes to the major, and that's why we also want to talk to students about it. And one of them is it comes now in 3 concentrations, but as Dawn said, we can tailor everything to your needs. I mean, we're very flexible. But essentially, it comes in 3 concentrations. One is pre-med concentration. This is set up so that it incorporates pre-med requirements to minimize your credit hours that you need, because you all know if you are pre-med, that you have to take a lot of credit hours. And this is set up so that you have to fit your pre-med requirements nicely into the biomedical physics program, so that your credit hours are staying kind of under control. So a lot of these courses you take for pre-med, we will accept for the biomedical physics program. Or if you would want to be a biophysics researcher, you're thinking about going into you know, a graduate school, maybe in biophysics or biomedical engineering or other kind of fields, related fields, biochemistry maybe or something like that. You can do the biophysics concentration, which has a bit more you know, sciencey kind of courses that gives you more training in some biophysical techniques and things like that. And then we have a medical physics concentration. This will work out with the medical physics program at Wayne State. This gives you some extra course that they require if you want to become a medical physicist, which is a very good career to have. Those are the people who really calibrate, for example, the radiation for cancer treatments, and they're very well paid people, but they do require some extra courses, so that is a slightly more rigorous path to take if you go that path. Okay. Now, why would you be, if you want to be a pre-med, just to mention that, in 2012 there was a study done, and they looked at now the scores are different for MCATs now. I know that they have a different scoring system. This is based on the old scoring system, but these are some majors that people had and how they did on average on the pre-meds. You can see that physicists do very, very well on the MCAT, which is the test you have to take to become a medical student. So we have quite a good success rate, and you can see that biomedical physics is kind of in between physics and biomedical engineering. So I kind of, you know, fits right up there. So our students have done very well getting into medical school. So that's something to keep in mind. Now, I mentioned research. We really pride ourselves that we get pretty much all of our students into some kind of undergraduate research. And biomedical physics is home of one of the longest existing undergraduate research programs at Wayne State, which is called the Richard Barber Undergraduate Interdisciplinary Research Program. It funds students for the summer and during the regular semesters. It's interdisciplinary, meaning we don't just actually only allow faculty from our department to work with you, but you can work with faculty from the medical school, from engineering, from biology, from math, I mean, all kinds of departments have participated in this program. So that's a really unique program that we have. Now, where are our students that actually graduate with this program? As I said, the medical school success rate is quite good. Others have decided they actually like research more. They want to go into engineering. One area is biomedical engineering. So, for example, we have an A-grade program. So you can be a biomedical physics major, and then start taking some. They accept some of our courses, and with only one more year, you can get a biomedical engineering master's degree. So it's very unique. You can be in our college with the College of Arts and Sciences and our degree, but then actually get an A-grade program in biomedical engineering. We're also setting up right now an A-grade program in physics. We do have a physics A-grade program, but sometimes it's a little bit more difficult to switch from biomedical physics to regular physics because the courses are quite different. Biomedical physics is really a unique program with its own courses. So we're setting up, we reformed our master's program, so you'll also be able to just do a biomedical physics flavored master's program in physics itself. So so that you will have grad. And now I just heard that they're setting up a genetics, some kind of genetics program over the medical school, and we're going to participate in that too. And eventually that will come online as an A-grade program. So you have we'll have 3 choices of doing a 4+1 program with an undergrad and then doing a master's degree in either physics, biomedical engineering, or in a genetics program. Now, students also go into graduate school in physics, biophysics, medical physics, chemical engineering, material science. All kinds of fields are opened up to you. And of course, pre-professional programs. In addition to med school, people go to pharmacy, dentistry, all kinds of things are available to you. So yesterday, I spent quite a bit of time to look at some job descriptions of students that graduated from our programs. And these are job descriptions of actual students that were in our programs. I'll just read this real quick. One of them is a NVH engineer. I had to look that one up. That is apparently noise, vibrations, and what was H? Anyway, it's somebody who makes sure that your car doesn't rattle, right? So one of our students ended up as an engineer at Ford, another one at a research corporation, another one at another research corporation, a product engineer for Lear, and then we have a bunch of medical, basically residents already, internal medicine resident at Metro Health, chief resident at St. Mary Mercy Hospital, cardiology fellow at Henry Ford Hospital, gynecology oncology fellow at the University of California, San Diego. Then we have a pharmacologist at the Food and Drug Administration, the federal government. We have a public health research specialist at the Michigan School of Public Health. Pulmonary critical care fellow, another medical school at Henry Ford, and resident physician in internal medicine at St. Joseph Mercy Hospital. We have researchers, postdoctoral researchers at the Wayne State School of Medicine, at the Penn State College of Medicine, at Stanford. We have a director of education who works at Stanford University in California. We have PhD candidates at Yale, at the University of Chicago. These are top universities in the country. So these are some examples of people that have graduated from this program and what they have done with it, which I find really pretty amazing, quite honestly. Now, I want to talk a bit about, I know this is important for career. I'm not going to lie to you that biomedical physics is one of the easiest degrees that we have around. I mean, it's probably not. It's we say it's a challenging degree. It's comparable to doing an engineering degree, for example. But as you can see, the outcomes are very good. So this is from a study from Georgetown University, engineering on average. There's many different types of engineering. It can range from median salaries of 76 to 136,000. If you make 136,000 as a median salary, you have to become a petroleum engineer and work for the oil industry. Okay, so just if you want to know how you get to the highest number there. So physics is right in there with the engineers at 81,000. And then other science degrees are actually lower than that. And I'm not going to read all of them. So it can be a really good career choice to do this kind of degree. So we have a community. Actually, I saw that Kaylin just came. So we have our own undergraduate research conference in physics. We also have the Society of Physics students, and maybe Kaylin can say a few words about that. Are you there? I saw you come in.
Society of Physics students is one of the student organizations on campus, and we're just a community of people that like physics. You don't even have to be a physics major to be in it, and we share different research opportunities and advice and homework help and have different events throughout the year, like the undergraduate research conference in November for our physics students.
Yeah, and just to mention, we usually have social events, but as you all know, that's been kind of difficult because of COVID. But we hope that we get back into having some of those social events. It's going to get a bit difficult to do it outside but maybe we can do. Maybe we can do something. We'll see if it's not too cold. Maybe people can wear coats or something. We'll see. But yeah, we have a lot of social events, and usually when there's no COVID going around, and so that's a really good way of connecting with other students. So you already met some of our students and faculty. So as I said, we have a bunch of events. The Society of Physics students goes on campus. We have undergraduate research events. We have the BABA program. So I'm going to wrap it up there because I want to give time for you to ask questions. So if you need more information, if you want to really know about the courses, you really need the information how to get into the major. The best way to start is to start with Dawn. You can contact me, of course, anytime with questions, anything in the presentation and so on that you may be interested in. The faculty advisor, Dr. Zhifeng Wang. Undergraduate research and the Society of Physics students, Professor Kelly, who couldn't be here today, but he runs the BABA program and also is the connection to the Society of Physics students. Of course, for the Society of Physics students, you can also contact Kaylin, which I should have mentioned here. And I think they're updating their website in the near future. And then we also obviously we have a physics website where biomedical physics also listed there, and you can look at the courses. You can see it's really its own unique program. Kaylin just put her contact information in the chat, so if you want to get that, and there's also a email address for the Society of Physics students at Wayne State. You can email them also. Okay, that's all I have. I'm going to stop sharing here, and hopefully I'll be happy to kind of answer your questions. Anybody wants to ask some questions to any of us, Dawn, me, Kaylin, any of the other biomedical physics students? Please don't be shy.
There was a question in the chat about signing up for a physician assistant program. If you want to, I can just actually, if you want to just put your access ID in there, I can give you information about that. But we have had biomedical physics students that then have pursued physician assistant. So,
yeah, actually, the student who ended up being the director of education in the MSPA program at Stanford actually started as a physician assistant program in Chicago. So that was, she's doing extremely well there. And I mean, she's in Stanford now, obviously, must be doing really well. But she started with biomedical physics undergrad, went to a physician assistant program in Chicago, and now is at Stanford. So, so that's definitely something that can be done. So what are different similarities with biomedical engineering? So both are really great programs. The emphasis between engineering and science is always a little bit different. So engineering is always more about, I would say, designing things, like devices. for example, prostheses or something like that. So it's really an engineering discipline. Biomedical physics is a science discipline, so we are more interested in trying to figure out how things really work on a molecular level, and do have more of an approach of figuring out the physics, the biology, the chemistry of how life actually works, and learning how to use experiments and computer simulations to learn more about that. Now, as I said, we do have this connection with biomedical engineering because the kind of background you get in our program sets you up quite well to do a master's degree in biomedical engineering. There's actually a difference between the undergrad of biomedical engineering and the graduate school in biomedical engineering. A lot of the researchers in biomedical engineering actually do more sciencey type things. A lot of them do kind of molecular type stuff or computer simulations, things like that. So they're quite happy to get our students because they're kind of trained in that area. If you want to go out and actually work on designing devices, medical devices for people that such as prosthesis, then you're much better off with a biomedical engineering degree, I would say. But if you're interested in kind of how life works on a fundamental level and want to get that kind of computation experimental science background, that's what we offer. So that's kind of the difference.
Thank you.
So I have a little bit of experience with that because I'm actually, my PhD is in material science and engineering. So my PhD is in engineering. So I have some idea between the difference between engineering and science. There's a lot of overlap. I'm an adjunct professor in chemical engineering, material science over there also. So I know how both things work, and it's a lot of overlap, but basically we kind of offer the more of the science approach to things. Any other questions? You can either type it in the chat or just speak up. Don't be shy.
While people are thinking of questions, if I could mention that, the A grade, the 1 year additional to get a master's degree in biomedical engineering, we've had many of our students actually get the Bachelor's of Science in Biomedical Physics, then do the 1 year, what they call the A grade accelerated graduate program to get the master's in biomedical engineering. And then after that, go to medical school or go on to professional school. So there's lots of different opportunities.
Yeah, if I could also actually ask you all, I know one of them already did it. If you wouldn't mind putting your access IDs into the chat, then we can get back to you with some more information and email you. If you don't mind, just put your access ID in the chat. And if you want to do that with a question, that would be even better. But not required. You can just put your access ID in there. So we have another question here. From Nadia. My major is biomedical engineering. I would like to specialize in pharmaceutical engineering. So which major would best to opportunities? Well, that's a interesting one. So the one student here that I know about, who is the pharmacologist at the Food and Drug Administration, what she did is she did a biomedical physics undergrad, and then she went into chemical engineering PhD. So she went over to the chemical engineering, which you can very easily do with a biomedical physics undergrad. And she did a PhD over there in chemical engineering, and now she's doing this. What I would say, if you do a biomedical physics degree, I think that would be a good degree to do something like that. Definitely make sure you take a bit more chemistry with it, because pharmaceuticals, of course, we don't require quite as much organic chemistry. So you would probably want to take a bit more organic chemistry, a bit more biochemistry, and maybe think about getting a master's degree or something like that in chemical engineering, because ultimately, pharmaceutical engineering is about making chemicals. And so if you have that kind of bio background from biomedical physics, have taken a bit more chemistry and then go into kind of chemical engineering, I think you'll probably be pretty well prepared for something like that, would be my guess. So that's what our student did to actually, there's a pharmacologist at the FDA. Let's see, any other questions? Again, please, if you haven't done it yet, please put your access ID into the, what labs and research do you guys offer? Okay, So labs, we have lab courses, of course. So there we have an electronics lab, an optics lab, an advanced biomedical physics lab, where we do kind of some single molecule based kind of research in there. In terms of actual research, you heard, I don't know if you were here in the yeah, you were, Davide, you were here, yeah. So you heard some of the research some of my colleagues are doing. So it can be anything from doing optical techniques to look at transport in cells or between cells, or doing kind of materials type research. It can be doing in my lab we do atomic force microscopy, so that's a way of measuring tiny forces between things, for example between proteins or proteins on cells. Sarah's nodding because she's worked in my lab. And as you heard Mindy talking, Professor Wang, that we're doing computer simulations. So if you're more like a programming person, we like to do computer programming, that we can do. So there's all kinds of things that being done. I think a lot of it is basically molecular and cell level kind of. Okay, forensic science. Okay, so I think that biomedical physics could be a helpful degree in that direction. I mean, we don't have direct classes in that direction, but forensic science ultimately comes down to analytical thinking, having a good background in physics, chemistry, and biology, having a hands-on experience with the different technologies, and these days they're using a lot of computers too, because a lot of computer reconstruction of things. So I think it would be a good path to take that.
Yeah, if I can interject, I actually have a couple biomedical physics minors and majors that are also pairing it with criminal justice and forensics.
Yeah.
So yeah.
I think
So
I think it would be, that would give it a science background, that then pairing it with understanding the criminal justice side of things. Yeah, I think that would be a good, and you have to do a master's, as you all know. If you're in the College of Arts and Science, you do have to do a minor, and so minoring, for example, in criminal justice, with a biomedical physics degree is probably, it would be an interesting path to take. You can minor in anything together. I mean, that's the other nice thing, is like we're trying to be very flexible. You can minor anything with your biomedical physics degree. There's really no reason not to minor in languages or criminal justice or English if you want to be a science writer, or or one of the science disciplines, of course, makes a lot of sense. Anything will work. We also have a biomedical physics minor, I should mention that. So you can also be a major in something else and do a biomedical physics minor. That's also possible. So Roy mentioned that he actually has a friend who's planning on doing that, right? Good. Any more questions?
I just wanted to interject on the previous question about labs and research. The biomedical physics, it being such an interdisciplinary program, you're not really like limited to physics.
Right.
In my experience, through the Richard Barber program, I did research in a biolab, and through the MARC program, I'm now doing research in a chem lab. So I have personally gotten skills in the biomedical physics that I am now applying in other labs that are like, I've been sought out for that knowledge base. So you're definitely not just limited to the physics labs on campus. You could potentially do research in other areas as well.
Yeah, I think some of our students have worked in engineering labs, chemistry labs, biology labs, medical labs, any of those.
Yeah, just to like add on to that, it's a bit different, but I'm in the process of applying for a research fellowship Fulbright, and you have to like contact your own host, it's like potential host institutions, and the one that I'm currently working with, they like were specifically interested and said that they'd work with me because of my BMP major. They wanted somebody that had an understanding of biology, but could also code and had a really good understanding of math. And so if it wasn't for my BMP degree, I wouldn't be able to have that opportunity. And that's at the Hanover Medical School. So I think BMP definitely pays off.
Yeah, great. Thanks, Sarah. Yeah, I think that it's that combination of having the biology background, but then also being able to do math and computing at the same time.
And we just heard from Kaylin and also from Sarah. I just saw that Biola just joined us. I don't know if you want to unmute yourself and say hello.
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 Say a few words about yourself. That would be great.
I'm a sophomore, majoring in biomedical physics, minor in public health. I'm angling towards the pre-medical track. Yeah.
Great. I think that's also a really good choice, because there's a lot of interest in public health. Again, having more of that math background on top of that, it's also a good combination. So there was a question: does biomedical physics analyze bigger systems? We do. I mean, when it comes to the upper level class, we focus a little bit more on cellular and biomolecular things, and also medical technology, as I mentioned. But obviously, taking the basic physics classes, we do talk about mechanics and things like that. I think it would be quite easy for somebody in biomedical physics to kind of learn how to deal with bigger systems, since you do learn all the physics, the math, and the computational approaches to do that. But we don't have specific classes on, say, biomechanics of the body or something like that, which you probably will find more in biomedical engineering. Zhifang, you want to say something about that?
Right. So I want to join this example of one of our BMP students, and she worked as an intern position for a hospital, I think in Grand Rapids. That was a few years ago. And actually, she's working on the analysis of the body motion. So particularly for the help of the a patient when they have some difficulty for the body motion, and then do the text and then also run the program, the computer coding or programming to do that. So that is for the full body motion. Although we didn't provide specific class for that, but she says she has absolutely no problem, can get into that very fast because just use the knowledge we learn from physics. So in principle, you have no problem at all, at least from the example I saw.
Yeah, I think that that's maybe another difference between sometimes engineering and science is that engineering, you will learn a lot of specific tools that are used in industry, and that can be good in getting the initial job. But in the long run, those tools change, and what industry do change. And so what we are kind of pride ourselves is in teaching you really much more of the basics of really being able that kind of analytical thinker who can work themselves into any area of science and engineering in the future. I'm not saying that the engineers can do that; they can do that too. Especially since I have an engineering degree too. But really, that's kind of, so you're not limited. You shouldn't kind of look too narrowly at the specific courses you're taking. You should more look at the kind of like general skills you're learning that you can then apply to a lot of different things. Any more questions? We're happy to answer.
I'll just make a comment if I can. One of the things that I've been just, really amazed at is the diversity of what our students do with a biomedical physics degree.
Yeah.
And even undergraduate program, not just with their academics, but other things that they're involved in. And just, involved in different organizations, clubs, and leadership in various capacities. In fact, Roy had introduced himself earlier. If you don't mind, Roy, I know that you're involved in different things in the university. As a biomedical physics student, would you mind just saying a few more things about that, like what you are doing?
Yeah, gladly. So outside of academics and outside of biomedical physics, I'm minoring in Israeli studies. Being originally from Israel, definitely a little bit biased towards it. But I definitely made a lot of academic relationships with a lot of professors outside of the STEM field, which may seem kind of counterintuitive, but it really helps diversify. Going back to what Sarah was saying, it really goes to a lot of diversification of your qualities. And of course, outside of classes, well involved with quite a few cultural organizations, Greek life on campus, which again, the academic side of biomedical physics, I absolutely fell in love with. And then the community that came with it just really brought me deeper into it.
Oh, that's great. I think it really can be combined with a lot of things. I think one thing I noticed, a lot of our students in biomedical physics have a minor in languages, for example. That can be really good, you know, having that kind of science background, but then also learning another language, and then that opens up a whole nother list of opportunities. So, you know, anything can be combined, and whatever your interests are. Dawn is super advisor, one of the absolutely best, the best, we say, but on campus. So she can figure out any combination you want to do, no problem.
Well, thank you, Peter. I think, you know, one of the most important things is, you know, as we think about, you know, what your interests are, your goals, you know, as a student, you know, we're basically thinking of your future, right? You know, so each plan is very individualized, very tailored, specific to you. So again, you know, I welcome anybody to come visit me. As Professor Hoffman and other students will say, we have a great department. We're kind of a close-knit department. You know, it's kind of like a family, it feels like, you know, that you kind of belong, and, you know, you can lean on each other, support each other, especially when your classes get, you know, tough, or you have an exam or something like that. And you just need kind of like an out, you know, just kind of say, oh, you know, and get a little bit stressed. We're a great department. And so, you know, we'd love to have you, you know, either a major or a minor. But if you're interested, you know, come and talk to me.
Ah, okay. So Kaylin, Sarah, Roy, all in the same class. Which class is that?
We're in applied computational methods, electronics, in the electronics lab.
All right. Okay, good. Great. Excellent. Okay, are there any more questions? If not, we'll let you get on with your Friday and get ready for the weekend. Not sure what everybody's doing, but hopefully something good. If you think of still of some questions, as I said, you have the contact information. I will send you a copy, a PDF copy of the talk. Maybe you can share it with other friends of yours. Also, we'll figure out how to make the recording available. You know, hopefully we can put that on the website, and then you can watch it again, or also again share it with your friends. Any last minute questions before we wrap up? Oh, where can I find the recording? Yeah, we're going to figure that out. So we'll email you. We're going to try to put it on the website, or maybe send you a sharing. I don't know. I have to figure out what the best way, but we'll let you know. Maybe you have to have a physics. I don't know if we have a physics YouTube channel. I suppose we can put it there. That would make sense. So okay, I'll figure it out. We'll figure it out. So we'll let you know. We have your information. All right. So thank you very much, and have a great rest of the day.
Bye, everyone.
Bye.